let's start this section 5.2. Now we are going to talk about events. Okay, still we use events. I told you this is event, but you didn't see the real explanation about events. First of all, we discussed about the event. Before we do that, let me explain this. You know what is the what is the uh, if you have a question, you know what is the all possible outcomes, how you mentioned the all possible outcomes, right? So that all possible outcomes we call sample space. Here you can see sample space. It's the name we used to mention that it's the all possible outcomes in your experiment. Okay, it depends on your experiment, but we call it sample space. Okay, you don't need this notation, but sometimes we use it as omega or like this or like this, something like this. Okay, but you don't need these notations. In general, we use that sample space. So it is the all possible outcomes in your experiment. Okay, event, collection of outcomes of the experiment that based on your uh, goal. Which subset you need to extract from the subset, we call it an event. Okay, so event occurs, event triggers if and only if the outcome of the experiment is member of event. Okay, okay, consider this. I have my sample space. Okay, sample space means all possible outcomes for rolling a die. Okay, I have a sample space for rolling a die, so that I have my sample space. We write it like this, rolling a die. So sorry, 1 2 3 up to 6, right? My event is having a tail. Okay, my event is having a tail. So can we consider it as an event or not? No, because it is not included in my sample space or within all possible outcomes. Clear? So if it is an event, it is a member of that particular sample space, full set or small subset. It doesn't matter. Okay, clear? A notation for these events like this. Events we denote by capital letters. A equals what? A means, for example, A is having a tail. Something like that, based on your experiment, something like this. Okay, so that you can use this capital A whenever you need, like probability of that event, which means probability of capital A, right? Because you have already defined what is your event. Clear? So in the exams or no homework, I don't think, but for in the exams, if you have a short answer questions, then first define what is your event like this using a capital letter, so that after that you can use that capital letter in your solution set, like probability of A, which means you can pronounce this like probability of event A, something like that. I think next slide you can see that, or not, next one. Later you will see how you pronounce it. Like it explains something. It explains the probability of that guy within the bracket. Okay, so yes, you can see that. Example 4, tossing a coin. So what is the sample space within these curly brackets? Head and tail, right? Event A, you don't need to write event A, just write it A equals. Okay, side above is the head, which means having a head. This is your event. Once you need to find the probability of this guy, you can simply write probability of A equals something. Okay, simply here, how many heads? I mean, if you flip a coin once, you can have only head once, right? So there are only one occurrence divide by total 2, something like this. Okay, clear? Okay, next one, tossing 2 coins. Sample space, I think last time I showed you what is the sample space for this kind of example. This time it is 2. Last time we did for 3. Head, 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 tail, tail, head, and tail, tail. Right? This is the sample space, all possible outcomes. Next, event B, or simply you can write B, at least one head, at least one head. So let's write it, at least one head. So what are the at least? At least mean the minimum one and maximum, it can be any value, but here you had to restrict up to 2, right? So one head, which at least one head mean head, 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 tail, head, tail, tail, head, right? At least one head. Tail, tail, no, there is no head. At least 2 heads. At least 2 means minimum 2, maximum any value, but here you have 2 flips, so your event should be it's this one, at least 2 heads, right? Head, tail, or tail, head, no, because it is just one head. Head, head, clear? No heads, what's mean this no heads? No heads mean there should not at least one head, right? Which means tail, tail, right? So these outcomes, this one, this one, this one, whatever, based on your sample space, those outcomes should be there in your subspace or sample space, right? You cannot, you will not see any outcome outside this sample space. Clear? Each and every event should within that particular sample space. So each event, we call each event is a subset of this sample space. Is a subset of this sample space. In mathematics, if you would like, we can denote it like if your sample space is capital S. So S, yeah, let's say event B. Event B is a subset of S. You don't need to worry about these notations, but this is how we denote it. So each event is a subset of this sample space. Okay. Last one, I'm not going to do that. It is one head and one tail. So definitely one head and one tail. So head, tail, or tail, head. Okay. Let me do the. No, I think I did a similar example last day. Let me. So you know what are the prime numbers, right? 1, 3, right? 5, which means that value we can get by only by multiplying that value times 1, something like that. Okay, there are no factors for that particular number. Clear? 111. Oh no, yes, 111, something like that. Clear? 13. What is 7? 14, 15, 16, 17. Right? Those are the prime numbers. Okay. Okay. Rolling a die, just one. Okay. Sample space 1 to 6. I'm not going to write everything, but 1 to 6. Okay. You should write everything 1, 2, 3, 4, 5, 6, 5, 6. Everything. Okay. Don't put like these dots. Okay. Event. F means up face. Okay. Face shows a prime number, which means within this boundary, prime numbers can be 1, 2, 3, 3, 5, right? Only 3 possible outcomes, right? So 1, 3, 5. Sometimes I don't know, some books they just forget about 1. It depends. I don't know why, but sometimes it depends, because 1 can appear every time. 3 times 1, maybe 4 times 1. So I don't know. Sometimes they just remove 1, but I consider 1 as a prime number, so it doesn't matter. Okay. Do we have? No, we don't have answers, but okay. These are the prime numbers within this boundary, 1 to 6. Okay. Upface shows an even number. Even numbers are 1, 3, 5. Right? Even number. So it is same as this one. Clear? Okay. Oh, sorry. Thank you. It is not odd. Okay, sorry. Even numbers. I'm so sorry. Those are 2, 2, 4, 6. Okay. Don't confuse. Just tell me if I'm wrong. Okay. Okay. I just saw the next one. That's why the problem. Odd numbers. Okay. Odd numbers 1, 3, 5. This is how you write it. Okay. This is not here. We don't talk about a probability. We talk about an event. Talk about an event. This event, which means these possibilities, right? If you need to find a probability, it is another case. Okay. So here you have to write it within these curly brackets. These are not like letters E. These are curly brackets. Okay. My curly brackets are like that. So sorry. Within that, you can write 1, 3, 5. Rolling 2 dice, I'm not going to do that. Sum of the faces greater than 10. So sum greater than 10 means greater than 10. So it is strictly greater than. So it can be 11 and 12. So we have to find what are the possibilities that we can get from for 11 and 12. 6, 6, 6, 5, 5, 6, something like that. Okay. So you have to write all the. Okay. Now, let me remove this. Try hide. Okay, hide. Okay, Venn diagrams. This is this diagram is something like very old. Okay, very old, but still we use this because for simple probability stuff or simple events, we can easily illustrate them using this Venn diagrams for simple cases. Okay, complex cases we cannot use this Venn diagrams, but simple case like flipping a coin or 2 times, 3 times, doesn't matter. Rolling a die, just 2 dice, 3 dice, doesn't matter. Something like that. Very general examples we can illustrate using this Venn diagrams. It's a picture. Okay, we use shapes. We use shapes to mention or to illustrate what we have in our sample space. That's the idea behind this. Okay, sample space we mention in this Venn diagram. Sample space in general we mention using a shape. Let's say that shape is a rectangle. Okay, rectangle. Only rule is one and only rule in this Venn diagram is all shapes they must be closed. Okay, there are no open shapes like circle. It's like this, open on the top. No, everything should be closed. That's the one and only rule in this Venn diagram. Okay, only closed sets. So in Venn diagrams, we denote the sample space. First, sample space like a rectangle in general, but believe me, you can use any other shapes as well. But try to stick with this notation using a rectangle. Whatever inside this rectangle, we consider as the sample space. Okay, you don't have to worry about individual sample space values, individual occurrences. Okay, this box mention everything. Okay, any area you consider in this within this sample space, it is an event. Okay, I don't know what, but it is an event. Okay, okay. Let me erase this. Okay, events are drawn as disk inside the rectangle, but yes, you can use this. Yes, in general we use circles, but again you can use any shapes like triangles, doesn't matter, but they have mentioned, okay, use rectangle for sample space and disk for mention the events. Okay, so it's like this. My event A, don't think about what is event A. This is my event A. This circle is my event A. Whatever inside this circle, it is the event. So then you can name this event. Okay, because if you draw something like this, I don't know what is this, what is this circle. So you can name it using an arrow or something like this, or you can use arrow or just put a line, that's fine. Okay, anyway, you have to point out, okay, this is my event A, this is my event B, like this. Okay, sometimes we have to color these shapes. We will see that later. Okay, first, before we go through these Venn diagrams, you should know these things. Please remember these three. These are just words. Not E mean, E doesn't, here capital letters mean events, okay, any events. Not E mean, E does not occur. We can simply like in different books, they have mentioned using different notation. Sometimes we can use E on the top, C. C mean complement. E complement mean not E. Or sometimes we use it, it's like E dash, which means complement. Okay, sometimes I mean, I showed you this because some books, if you read books or read papers, you will see these different notations, but they mention the same thing. Okay, E complement means not E, this one. E dash means not E. Okay, or you can stick with this notation, that's also fine. Anyway, you have mentioned not E, which means I know that is the complement of this event. Okay, next one, A and B, both A and B, you can write it like A and B, is also fine. A and B. Later you will see there is another notation, intersection notation. You can replace and using that intersect notation as well. Okay, A and B, which means both A and B, they occurs at the same time. They occur at the same time, like a intersection. Okay, A or B mean A, yeah, A or B is like this. A or B, the event either A or B or both. So three things can happen. Only A, yes. Only B, yes. And also combination of these two, A and B, yes. Okay. If you have O, you have to remember this, A, B, or both. But if you have and, definitely third one, both, A and B. Okay, let's see this. Let's check this one. You have three Venn diagrams based on different events. Events mention capital letters, so consider first one based on this, not E. So you have your sample space, this box is a rectangle or any shape as I mentioned. Event A, you can mention it like this, this circle means your event E, but you need not E, complement, which means this area. You need this area, whatever samples or whatever occurrence observations in this area. So that's why they color this. Normally we color this area based on what they ask. Okay, next one, event A and B, you have two events. If we have two events or more, we normally draw it like this with intersection. Okay, if they haven't mentioned specifically, they don't have intersections, then we draw it like this with intersections. Okay, so A, B, or you can write it, you can draw it like, as I mentioned before, A, this is my B, this is my A, something like that. That's fine. Okay, then what is A and B? A and B, it is the intersection. A and B both occur at the same time. O, combination of these two. Clear? O means A or B. Either A only mean this part, B only mean this part, right? A and B mean this part. So all together you have A or B, right? Okay. Clear? Okay, let's check this one. 5 possible board members, 3 to 5 years. Possible outcomes can be represented as follows. They have given all possible outcomes, which means your sample space. Okay. X. Okay, even what is event X? Victoria is selected. So V is selected. V is selected, you can find. So what are the events? What are the outcomes? V. This one. V. This one. V. Right? So EDV, EVL, finally VLA. Okay, this one. Clear? Those are X. Event Y, that event that David and E, David and Emily, D and E, D and E. So D and E both in this occurrences. So D, E, yes, this is a Y. I'll write it like this. Okay, D, E, yes, right? D, E. Do you have any others? No, right? Third one, event that fewer than 2 men are selected. We have D, means D, Victoria, Lily, Andrew. We have only David and Andrew, right? Men. So fewer than 2 men, strictly fewer than, is strictly less than, right? 2 men. So it should be only one man, either David or, yes, David or Andrew, not both. Okay. DA should not be there. So this is C. D, yes. No, this is not right, because D and A both in this case. So we need only fewer than, right? Even that fewer than 2 men, yes. So we need only one. So we cannot consider this one for this capital C event. DOA. Yes, we can consider this. Yes. DOA. Yes. No. This is not. This is not. And this is yes. Sorry. This is yes. Right? So likewise, you have to identify and please write it down, write it in front of these samples. I didn't write it, but please mention them. What are they? Okay. Now, not X. X mean my circled one. So not X mean whatever not include to X. X, which means X are this one, these circled ones. You have write your samples except those circles. EDA, right? ELA, DLA. Clear? Please check it. Okay, if I did something wrong, please let me know. Okay, X and Y, and mean though both should be there. X and Y. What is X? These circles. What is Y? On the top I have mentioned Y. So circle and Y. First one, yes, right? So first one EDV. Second one Y, yes, but no, X, no. So it is not. Circle and Y. Is that all? Yes, right? That's all. That's it. Just one occurrence. Both Y and X. Okay. If you write it in this form, it is easy to understand. Okay. Okay. O, X, O, C, X, O, C. So X, yes, you can write X occurrences and Z occurrences or both. Doesn't matter. I can first I'll write what are the X occurrences. EDV, C is also there. Then X, EVL. I'm considering X only. Okay. EVA, EVL, DVA, and VLA. These are the X only. I mean X occurrences. Now consider C occurrences. This one, yes, we have written it here. This one, no. Then you can add this one as well. Clear? Z. Any other Z? Yes. This one, X, yes, and C also, yes. So it is there. This one, this one, yes, but this one is not there. So you have to add it. EL. Right? So either X or Z or both. I already added every occurrence in based on X or Z, right? Okay, let me write. I'm not going to do this one, but let me write these possibilities. Y means Emily and David, ED. So E, D, V, EDL, EDA. That's it. C means EDV, EDL, ZCC, EVA, ELA, comma, DVL, BLA. Okay, those are the outcomes. Clear? Questions? If you missed any of these, you will get the wrong answer. Okay, so please pay your attention when you are differentiate these events. Okay, when you are differentiating these events, please make sure, I mean, check at least once you wrote it, check at least one, okay, whether it is correct or not. Okay, this one I'm not going to do that. Is very similar to previous example, but please try this. Okay, so your exam questions like this, written questions, I mean short answer questions like this, right? You have to mention the sample space, event space, or and these events. Okay, don't forget to mention them within these curly brackets. Okay, now there are different events that we can consider. Here we have mentioned one thing we call mutually exclusive event, which means those are two different events. They don't have a common space or shared area. Mutually exclusive event if no two of them have common, outcomes in common, they don't have common area or common outcome. They are like A is here, B is here. They don't have any relation. Okay, something like this. Using Venn diagram, we can mention it very easily like this. A, it is this one. B, it is this one. Right? Like this. They don't have a common area. Next one. Sorry. Yes, they have mentioned it here. This is the mutually exclusive event, and this is non-mutually exclusive event because they have a common space here. This can happen for more than two. It doesn't matter how many. More than two, we can have mutually exclusive events or non-mutually exclusive events. Here, the first one, definitely three mutually exclusive events. Yes, right? Second one, three non-mutually exclusive events. Third one, it should, here it is strong. It should be two non-mutually exclusive events. It should be two because there are two. See, this one is a one particular event. These two we can consider as a one event. So only C and that part AB has the mutually exclusive event. We can consider them as the mutually exclusive event. C and those two AB. Okay, so we have two non-mutually exclusive events in this case, right? There are no three non-mutually exclusive events. There are two, but don't worry, we don't ask how many mutually exclusive events, something like that. Okay? If you consider A and B together, then we have two mutual exclusive events. A and B, no, they don't have, I mean, they have a common space, so they are not mutually exclusive, but A or C or B and C, they are mutually exclusive. Okay, let's do this example. Here you can see the cards. There are 52 cards. Okay, number cards and picture cards based on four symbols. Okay, spades, hearts, clubs, diamonds. Okay, so based on this deck of cards, we can define our sample space as well as events. For the experiment of randomly selected cards, okay, 52, yes. So they have defined events A, B, C, D, four events. Selected is the king of hearts. So this should be K hearts. Event cards that selected is a king. So it doesn't matter. I'm writing the notations only, not the sample or not the event space. Okay, not the possibilities. I'm just writing the symbols. Event the select card is king. So it doesn't matter the symbol, either diamond, clubs, or whatever. We need a K. Event card says heart. Okay, then we need a heart. Doesn't matter what is the value. It's whether it's a number card or picture card. Doesn't matter. We need hearts. Even the card selected is a face card. Okay, we need a face here. Doesn't matter again. Doesn't matter about the symbol. We need the face card. So what are the face cards mean? Whatever in these three columns, right? You already know that. Right? Okay, so these are the events. First of all, you have to identify what are the events carefully. Okay, I'll do one. Let's say event A, which means K and hearts. K hearts. Event card is selected as the king of hearts. So K hearts. This one, right? So this is my event A. Clear? So likewise, we have to identify what are these events. Not D. D is face card. So not D mean what? D means face cards. This is your D. So not D mean this whole bunch. There are 3, 6, 12. So it's gonna be 40. Yes, it's gonna be 40. Do we? Ah, yes, we have. Okay, clear? B and C. So B and C mean K and hearts. So there are only one occurrence as I mentioned. Oh, hold on. Event card is selected King of Hearts. Yes. Oh, yes, yes. Right. Is this correct? This one? Event card that selected King of Hearts, right? It is just K hearts, right? So, okay. So B and C. B means king. C means heart. So B and C, which means it should be King of Hearts. Simply it is equals to event A. Clear? King of Hearts. So let's see. Let's do this one only. Okay. BOC. What is B? K. BOC. Hearts. So KO hearts. So what are the KO hearts? K, yes. KO hearts. So K means these four, right? K, kings. Okay, clear? Hearts means this part, this row. So you have to combine these two together. That's the BOC. Let me check. Yes. So is C? Yes, yes. See, this is the column, this is the last column, and this is the row. Clear? I don't know what is the D. Okay, D, C, and D. C and D mean these two. Heart, face card, but it should be a heart. Yes, hearts, hearts, face cards. These three. Face card, but it is a hearts. Clear? So if you have this kind of picture, yes, it is okay. We can do that. But if you don't have this picture, then you have to imagine what are the all possible outcomes like that. Okay. Questions? Questions? Okay. Now we can deal with not the probabilities. We can deal with numbers. Previous case, we just figured out what are the possible outcomes and denote them. But here we have numbers. Like you have to add them together to mention this is my event, not subtract, something like that. Okay. Let's see here 1 to 8 plus, which means those are the categories or classes, and you have the frequencies based on those classes, which means simply occurrences for each class. Based on that, we can define our events. I'll do just one example. Okay, which one do I need to do? First one, yes, it's this one, easiest one. Let me pick B. I'll do this one. Okay, so what is A? What is B? At most 4 rooms, which mean at most mean what? 4 less than or equal. Maximum can be 4 or equal 4. Okay. This one at least 2. At least 2 mean what? Greater than or equal to. So room can be greater than or equal to, less than or equal 4, right? Which means 2 to 4 inclusive. 2 to 4. Including 2 and 4, right? So this event means what? Summation of these three numbers. So event it is B and C, right? No, A and B. A and B, or A and B, simply A and B is summation of these three. So you can somewhere you can calculate them. 11, 4, 3, 3, 23,006. So add these two, the three together, and you can have the value. Okay. Okay. Later we will see how to find the probabilities, but now you have to define the event. Okay. Yes, we have enough time. Let me explain these rules. Probability notations. Yes, I have already mentioned you what is the notation. So notation is capital P. If you have event E, probability of E. See, probability of E. That's how we read it. Probability of E. Capital P means probability. E means event. Whatever inside this bracket, we denote the event. You can simply write it. Event is this one, or simply write it somewhere using a letter. E equals this event. Then use E in this notation. Similar thing. Okay. I think we don't need to do this example. This is how to mention sample space and event, how to write it. Balanced die. Rolling a balanced die means outcomes are 1 to 6. We have done. A means denote the. You have to write this for A. This is your A. You have to write it here. Here, like they have mentioned. A is what? So you have to write it. A is the event that the die comes up an even number. That one. Then you can use capital A anywhere. Like find the probability of A like this. Okay. Okay. Please remember those facts. I think we did 2 or 3. At least 3 here. At least 3 mean greater than or equal 3. Okay. But bounded to whatever value you have. At most, at most mean less than or equal. More than, strictly more than or less than mean strictly greater than or less than. Strictly, there are no equal sign. Okay. Then inclusive, between this one and this one, inclusive mean equal sign is there. Okay, you can consider the boundaries as well. Exclusive, you have to eliminate the boundaries. See. Okay. So these words you have to be careful with that if it is there. So don't miss them. If it is inclusive, then please consider. Sometimes you may have exclusives as well. Okay. Let me do this one. I think later we have example, so we can do this one for today's class. Okay. Okay. We have a formula. Let's say formula to find the values, the probability values, if we have disjoint or mutually exclusive events. That's very important. Okay, you know what are the mutually exclusive events? They are like this. A is this one, B is this one. They don't have common space. Those are the mutually exclusive. If we have 2 or more mutually exclusive events, we can find the probability of this. Probability, let's say we have 2. Probability of A or B, simply we can find by taking those two separate. Probability of A plus probability of B. Okay. If we have more events, doesn't matter how many, we can simply extend it to like this. See, A or B or C or D, whatever. Probability of A plus probability of B plus C, something like this. They are separate probabilities. Okay. It happens only under this condition, mutually exclusive. Your problem, what they have given to you, should satisfy this fact, mutually exclusive. If they don't, you cannot use this. Okay. Clear? This is okay. Let's do this only. Okay. I'm not going to do everything, but I'll give you a brief idea. This one is just a table. You know, these are first column is acres, which means what kind of numbers they are. They are continuous. Okay. So you can see this table is what? Cut point grouping. or what? Cut point or what? 10 to 49, 50 to 99. Yes, they are not cut point. What? Group, limit group. Okay. They have considered acres as what? Acres as discrete numbers. In general, acres are continuous numbers, but they have considered acres as a discrete numbers. That's why we have 10 to 49. Then next one is start from 50 to something, right? They have a gap because they have distinct values. Okay. Events they have mentioned in this column. So what is, okay? Let's do this one only. What is the event? Okay. What is the event? Just tell me those values. What is the event A and F? Give me a number. Oh, what is the event of A and B? Let's say, oh, okay. A and C. So what is the event? A and C. A and C, we don't have that kind of event. Why? Those lines or those rows or those classes, they are mutually exclusive. Why? If we have acres under 10, there it has nothing to do with acres in between 100 and 179. They are mutually exclusive. So what is A and C? Zero. I mean, null event. We call null event. We don't have that. If we have O, what is A, O, B? Simply summation of these two. Clear? Okay. So that's it for today. I'll go through this very brief in next day.